day. Thank you for attending today's webinar. We are going to hear today from Dave Vieglais and Amber Budden. They are from DataONE. Dave Vieglais is a Director of the Development and Operations, and Amber is a Director for Community Engagement and Outreach. If everyone could please mute your microphones, and you guys could ask any questions during the presentation. Go ahead.
Great, thank you very much, and thank you for this invitation to come and talk to you about DataONE. We do appreciate the opportunity. From the brief that we were given, we're really going to be focusing more on the infrastructure and the interoperability part of our project as opposed to some of the activities that we engage in. But we will kind of give a very brief overview of some of that. I'm not sure how familiar people are with DataONE, so I'm going to start with some background information before we kind of get into the nuts and bolts. For those of you that don't know, DataONE is an NSF-funded project that is funded through the Advanced Fiber Infrastructure Division at DataONE as part of the DataNet initiative. We were originally awarded in 2009 a 5-year award, and then we were renewed for an additional 5 years, which began in 2014. And so currently we're in the process of transitioning to a much more mixed model funding support structure. And so I wanted to highlight that DataONE is a project across many institutions. The information that we're presenting here is the work of many individuals. We use a very successful working group model in our organization where groups are formed to focus on specific tasks or activities. And so many of the people that you see pictured here are actually contributing their time and their expertise in kind. They believe in the work, the vision and mission of DataONE, and are excited to contribute as part of a working group team. Okay, Dave, next slide. So DataONE was designed to support researchers in the face of multiple science and data challenges that exist. For example, we know that
the conference has been unmuted.
We know that data across broad temporal, geographic, and spatial scales are required for us to answer some of the most pressing ecological challenges that are facing us. We also know that these data can be very difficult to discover and to access. And this is particularly true as the time since the period of data collection increases. So, for example, in that top right figure there, you can see some work by Tim Vines that was published looking at the probability of getting hold of some data according to the age of the paper. So on the x-axis, you have the amount of time since the paper was published, and on the y-axis, you essentially have the probability of being able to get those data. And so he went about taking a look at the literature and calling up researchers who are looking for those data online. And obviously, as time goes on, the probability of getting that information is significantly reduced. And this is sometimes called the file drawer problem. When we're not currently working on something, then being able to recall that information is more challenging. And so in response, there have been changes in the community. And for example, the government has issued a requirement for federally funded research data to be openly available and to researchers. Researchers are now working on these requirements, and so this means that people are looking for open access to repositories to put their data. And so even though there is this shift in the community that researchers are more aware of open access requirements and that they are more willing and motivated to share their data, there are still a lot of variation in standards and practices. And so the bottom right figure is some research that DataONE has done looking at metadata standards that are used within the community. And so we asked them about the metadata standard they use for describing their data, and we gave them a range of different options. And you can see there that one of the more common ones is my lab. They're not actually conforming to any given standard. They are just using something that has been put forward within their immediate community. And a lot of people are not applying any type of standard to describing their data at all. And so DataONE has worked in this field trying to understand the motivations and the challenges that are faced by the community, and that has really informed the development of our infrastructure. Okay, Dave? So the vision of DataONE is to provide universal access to data about life on Earth and the environment that sustains it. And we go about this in three primary ways. The first is through building community. The second, and this is the area that we're going to be focusing on today, is the development of sustainable data discovery and interoperability solutions. And then the third is to support researchers with tools and services. And so as I mentioned, we're going to be focusing on this second component, but I do want to emphasize that our development activities have really been heavily informed by extensive research and discussions with the community. As I mentioned, we have a working group model, and we have working group activities that have been dedicated to understanding motivations and concerns of researchers with respect to data sharing and preservation. We conduct usability testing of our products, and we include a user experience technologist as part of development planning. And we also have an annual meeting for the users of DataONE so that they can find out the most current information on what's going on, and we can get feedback from our user community. We provide education and support around DataONE tools and services, in addition to providing training in general areas of data management. Okay, so moving forward in this next section, I'm going to provide a very high-level summary of the infrastructure that is supporting our data discovery before I pass over to Dave, who's going to go into much more details with respect to the architecture. So at the core of DataONE is what we term our coordinating nodes. We have three coordinating nodes, one in California at UCSB, one at the University of New Mexico, and one in Tennessee at the Oak Ridge University of Tennessee campus. And these coordinating nodes are essentially the index for the metadata across all of the repositories. So they retain a complete metadata catalog. They manage the indexing for the search. So when you're conducting a search for data through DataONE, you're conducting a search on these coordinating nodes on this metadata catalog. The coordinating nodes are responsible for ensuring the network-wide services. They engage in replication services activities, and they ensure the content availability or preservation. By having three, we have redundancy in the system such that for any reason one goes down, people can still use DataONE and still access the data from the individual repositories. So in terms of what the coordinating nodes are coordinating, we term these member nodes. These are essentially repositories or organizations that are exposing their catalog through DataONE. So the member nodes hold their own copies of the data. They manage the data and they provide the metadata to DataONE coordinating nodes. Member nodes represent diverse institutions. They service their own local community. A number of member nodes might be domain-based, have a domain specificity. They may be institutionally based, for example, university libraries. And they provide resources for their community in terms of managing their data. And as I said, they retain copies of their data. And we have a very broad variety of member nodes within the DataONE network, focused primarily on Earth and environmental sciences. Okay, moving on. And the third component of the infrastructure is the investigator toolkit. And the tools within the toolkit that you can see there are tools that have either been created by DataONE or created in collaboration with DataONE or adapted to work with the DataONE infrastructure. Our search portal or our search interface is DataONE Search, and that is the way that you actually put a call on the coordinating nodes to access the data that's held within the network. DMP tool is a collaborative tool, for example, that enables people to go through a wizard in terms of writing a data management plan. For example, we have an R package that interacts with DataONE such that you can pull data from DataONE directly into your analyses using R script, etc. So as I mentioned, this is a very, very quick, broad, high-level overview, and Dave is going to go into a lot more of the technical detail associated with some of these components. Oh, in a moment. Thanks. But first of all, I just wanted to indicate the member nodes that we have in the network. As I mentioned, DataONE was initially funded in 2009, but we came online in 2014 in terms of having a user interface that people can search for data. And so this represents the timeline since 2012 and the member nodes that we have brought on board. We're currently basically at NEON. NEON was announced yesterday. That's the National Earth Observation Network, another NSF-funded initiative. And so we announced those yesterday, and we are constantly and currently working with a lot of other repositories to bring them into the Federation. And so these 31 repositories, plus we also have 3 nodes that act as replication nodes, creates a total of 34 member nodes. And across those 34 member nodes, we have currently, next slide, 400,000 data objects within the system and 227, I don't see the next slide, Dave. There we go. 227 odd metadata objects within the system. And so we track this information, we expose it to the repositories in the system, as well as exposing it to the public, to the community, so they can see the growth of data within the DataONE network. And we also have information on the time, the dates associated with the data. And so we have data that goes back into the 1800s, and then also file format information for people to take a look at. And if you go to that URL at the bottom there, you'll be able to see this live information for yourselves.
Thanks, Amber. I'm going to go into a little bit more detail about how the infrastructure actually works and how the data and the metadata are represented as data packages. So as Amber mentioned, the DataONE infrastructure is fundamentally made up of 3 components: the coordinating nodes, member nodes, and the investigator toolkit. Now, all these components communicate with each other over the internet using HTTPS and REST XML messaging. And all this interaction is defined by the DataONE service specifications, which really defines the services available on coordinating nodes and member nodes and how tools can interact with those services. The specifications are broken down into several APIs, and member nodes can participate at different levels of compliance. At the lowest level, member nodes can participate as public read-only repositories, all the way through to repositories that offer replication services and so forth to the overall network. The Investigator Toolkit is made up of many different components at the lowest level. These are several software libraries in Java, Python, and so forth. And these are all designed to help developers build additional tools to work with the infrastructure, but they're working through the same service specifications. And one of the benefits of having this consistent set of service specs is that any member node, regardless of the software that's used to implement the member node, as long as it's conforming with the service specifications, then a particular investigator tool, such as the R plugin or even the search interface, is able to interact with any of the nodes without any additional changes from that repository or from the client side. So that provides there's an initial cost to implementing the service interfaces, but amortized over time and the number of clients accessing the member nodes, the overall cost is very significantly reduced. Now, content in DataONE is, DataONE is meant to provide long-term access to archival information. And so all the content is static, it's immutable. So once a data set is added to the repository, it's always available in exactly the same bytes that was originally contributed. Data is described by science metadata, and each of these components has associated with its system metadata that provides low-level information about those particular documents. The relationship between metadata and data is recorded using semantics defined by the citation typing ontology, and these are documented in what's called resource maps. And these are open archives initiatives that we use in exchange conformant documents. They basically just contain assertions that this metadata describes its data and vice versa. And of course, there can be any number of data objects described by a particular science metadata document, and similarly, there can be any number of science metadata documents defined within a data package. Now, everything originates from member nodes. These are the data repositories that are actually contributing content. This is where people go to add to the network. And initially, the science metadata, resource maps, and data are added to the member node. The member node itself creates the associated system-level metadata. That's the type of content it is, the size of the content, things like that, checksum and so forth. And I'll point out now that every object added to DataONE, every data object, every resource map, and every metadata document has a global unique identifier associated with it, which is really convenient when you want to reference these data sets, either through an application or even in a publication. You just use a DOI or whatever identifier is being used to consistently and always refer to that exact data set. Now, the coordinating nodes synchronize their catalog with content that's available in the member nodes. And they do this by requesting a list of changes from the member nodes. And they initially pull down all the system metadata and then download also the metadata and resource map documents to the coordinating nodes so they can be indexed and made available. By pulling all this information together into the coordinating nodes, it offers a really convenient way for users to discover information or data sets that are relevant to a particular topic. And the way we process this is fairly straightforward. It's a fairly simple pipeline. Basically, we download the content and associated system metadata from the member nodes. We pass this science metadata and resource maps and the system metadata into a common structure. So in some cases, this means transformation of some of the content from the metadata. In some other cases, it's a direct transfer. But these all end up in a consistent record structure that's contained in a Solr index, which is a search index running on the coordinating nodes. And this is then accessible through the search user interface, which is available at cn.dataone.org. And also, any of the investigator tools are also able to interact with the search interface to facilitate discovery of content. The search UI is a fairly sophisticated interface. It provides a number of different ways of viewing the content. And of course, most of the content available in DataONE is spatially oriented. We provide an overall heat map of all the content that's available and its general distribution across the globe. You can zoom in and out on that heat map to identify how many data sets are available in a particular graticule, and that's one way to access content. You can also, of course, filter by various categories or fields within the Common Search Index and isolate particular data. If you want to get down to the details, you can look at a particular data set, of course, and access any of the particular components of that data set, including the actual metadata or any of the components contained therein. In this case, this particular data set has one metadata document and about 37 data sets associated with it. We also provide sort of high-level summary information about each of the member nodes that are participating. This is quite useful for member nodes and also people that are interested in the different member nodes in particular. Basic stats provided includes a number of downloads and uploads of content to that member node. And because we replicate content across all the member nodes, across most of the member nodes, another role of the coordinating nodes is to aggregate access information across all the participating nodes so that you can provide a complete total number of accesses to all the content for a particular member node. So another aspect that we recently added to DataONE capabilities is tracking provenance associated with derivations of data and creation of data sets. this provenance information provides additional information to investigators about how a particular data set was developed. And this is captured by various investigator tools and contributed along with the metadata as it's uploaded to a particular member node. The provenance information is directly viewable where available through the search interface, and it basically provides a high level, in the user interface, it provides a high level overview of the derivations of the different components of a particular data set. As the amount of content in DataONE increases and the diversity of content increases, relying on just conventional search techniques becomes progressively more challenging. So one feature that will be incorporated into DataONE is currently in beta testing. Will be available in about, it's a ways off yet, about 18 months or so. But it's basically incorporating more detailed semantics about the content. And so in the simple sense, one can provide a search term, in this case carbon, and then the system will prompt you for more information about what you actually mean by that term. Do you mean carbon flux, carbon dioxide, carbon mass, and so forth? And so in this way, it enables much more precise search capabilities by specifically identifying the data sets associated with that exact concept. And these concepts are referenced in various ontologies, and the extraction and association of ontology terms with the metadata is a partially automated process and partially manual at this stage. We're hoping to get to a completely automated process by the time of release. We also have on the cards incorporation of, or promotion of, data use metrics. And this is of considerable interest to investigators as well as data repositories sharing information. And these data use metrics really get at how often data sets are cited in publications or referenced in other means and in other systems. And this provides significantly more useful information than just the number of downloads or uploads for particular data sets. And this is, we've done a prototype of this technology and it's worked quite well, and we look forward to implementing this in the not too distant future. So that was a very, very quick high-level overview of the DataONE infrastructure and its various components. If you have questions, then I'd encourage you to take advantage of any of these technical resources. And I believe these slides will be available afterwards as well. And now I'll move back to Amber, who's going to talk a little bit more about the various activities in the DataONE project.
Okay, thanks, Dave. So yeah, to end, I just wanted to take a moment to highlight some of the resources that we provide and the ways in which we support our user community. We engage in a lot of in-person and online training activities. We run workshops at some of the large environmental science, earth science disciplinary meetings, and also run sessions and do outreach at those events. We also have a webinar series that runs during the academic year, so it's September through May. And these have been opportunities of for some broad level discussions in the space of data management, open access, etc., to be addressed. And so we bring in experts or leaders in the field to come and host a webinar to our community. And moving forward, we're going to incorporate more of our, sorry, back a slide, Dave. We're going to be incorporating more of our training materials into the webinars as well, so they're not a platform for discussion, but they're a platform for more kind of hands-on instruction and learning. We also, for each of the tools that we put out, we try to create a series of short video tutorials to serve as an alternative to kind of help, text-based help for people to navigate through how to use the tools. and we provide a lot of other resources that I'll go into a bit more detail. All of these activities are done in collaboration with partners in the community. We recognize there's a lot of people in the same space working on education and training and data management, and we want to make sure that we are reaching the broad community, but also that we're building on the work of others and what's already been done. And so some recent collaborations include Center for Open Science, the Earth Science Information Partners, IDIG BioSeed, and Terra Populus. So in terms of what we have on our website, one of the most highly visited areas of the website is our best practices database and primer. And this is a resource that provides guided best practices for many common data management tasks, and they're coordinated by the data lifecycle. So the DataONE data lifecycle that you can see a little bit in the top left there has 8 steps associated with it. These are plan, create, assure, describe, preserve, discover, integrate, and analyze. And so for each of these different steps of the data lifecycle, you can link out to a set of best practices that facilitates your learning in that particular area. And we recognize that not all research paths will be circular and won't necessarily touch on every step of the data lifecycle, but certainly for those that are involved, there is a guided set of best practices that facilitates working with data in that particular area. Moving forward, Dave, one of the other highly used areas of the website that I would point you to, point your community to, is a set of downloadable, editable CC0 education modules. And these were designed explicitly for people to be able to take them, whether it be faculty, librarians, data managers, etc., and use within their community for data management training. We recognize that people are very busy, and in the case of environmental science academics, they may not have the expertise in data management to have a curricula already developed, but they recognize that it needs to be taught at the undergraduate and graduate level. And so we were taking some of the burden of responsibility off them by providing these customizable materials that they are welcome to adapt. They have PowerPoints associated with them, hands-on activities, one-page synopses. And so while they're intended to be used for instruction, they're also great for self-learning. And they actually form the basis of the in-person training and workshop events that we run, as well as informing the upcoming webinar series. So finally, I have at the beginning indicated the value to DataONE of community feedback and involving the community in discussion of development and prioritization of our activities. We are fortunate that we have a very diverse and active DataONE users group, and we're actually heading out there this weekend to our in-person meeting. So I know that you are San Diego based, but if you find yourself in North Carolina this weekend, then please do feel free to come along. Dave and I will both be there, as well as some of the other leadership of DataONE and our broad community of users, and you're most welcome to join us. And with that, I have a bunch of links, the ways that you can connect with us, follow us, and see what we're up to. And of course, you can email Dave and I with any questions as well.
Does anybody have any questions?
Hi, this is Susanna Simpson from Oxford. Thank you very much for the very good presentation. I'm sorry, because I joined a little bit later, you might have already stated earlier, but I'd rather ask. Can you give an idea of somehow the size of the team that you have? How much does it take to support our user? You have a lot of material, which is brilliant. Just really to understand how much it takes to support the variety of users that you have and all the collaboration, especially for documentation, training material, and etc.
Dave, do you want to handle that, or?
Yeah, I'll talk about the technical side, and maybe you can talk a little bit about the educational side as well as promotion materials and workflows taking. So for member nodes participating in DataONE, there is an initial cost of effort associated with installing the appropriate software stack to enable the interoperability. But in the vast majority of cases, we're working with member nodes that have acted as data repositories for their communities for quite a number of years. And so they've already developed the relationship with their community of users and the various techniques and mechanisms for appropriately describing and capturing data from their users. And so in that respect, a lot of the costs associated with documenting and describing the data, that's part of the normal process of interacting with these different data repositories, and it's just part of the doing business of science is properly documenting the data and adding it to a repository for long-term capture and reuse. For ongoing maintenance of the infrastructure, there's actually very little cost associated with that. Of course, it's really an entirely automated system. The main costs are just associated with keeping hardware up to date and various software packages secure and up to date and so forth. And of course, any changes to user interfaces and so forth do take a fair bit of effort, especially with the amount of usability testing and feedback that we go through in DataONE to ensure everything is up to snuff as far as what the community wants. Now, the other side of providing educational materials to help with address these various costs and efforts of contributors. Maybe Andy can talk about how much effort it took to produce educational materials.
Yeah, so the education side of things, we have a very small in-house staff. As I mentioned at the beginning, we use a working group model, and so we do have a community engagement and education working group that comprises approximately 10 individuals. There's also a postdoc that works on the education side of things, and collectively we go through the process of creating, revising, editing the support materials. When it comes to more technical documentation, obviously we liaise heavily with the cyber infrastructure team, the developers, and so we do pull some of their time and activities on this. We're actually looking, again, I indicated that our funding from NSF ends in 2019, and so we are looking at a more diverse funding stream moving forward and looking at our sustainability options. And one of the things that we're looking at explicitly with education is moving into more of a crowdsource, open source space, such that we might move our education materials into GitHub and we have much more collaborative interaction via that space versus having a peer review editorial process, which is what we currently undertake with our education materials.
This is brilliant. Thank you very much. And perhaps I could suggest you also to look into also the data carpentry approach.
Yeah, so one of, I work quite closely with Data Carpentry. The Executive Director for Data Carpentry is one of the members of the Community Engagement and Outreach team. So we are looking at building our lessons into Data Carpentry lessons so that we can expose them through Data Carpentry. In some of the projects that DataONE is involved with, we also work with both software carpentry and data carpentry. So we do have very close connections with the carpentries, as it were.
Brilliant. I really appreciate very much because although I work in a more biomedical area, you have done a lot of work that some of which is very generalizable. So if this was in the data carpentry module, it would be really even higher reusable from other domains. Thank you so much.
Oh, you're welcome.
Are there any more questions? Okay, I guess there are no more questions. Well, thank you everybody for attending. Thank you, Amber, and thank you, Dave.
You're welcome.
Thank you for the opportunity. Really appreciate it.
So don't forget, next webinar will be August 11th. So see you next month. Thank you.
Bye-bye.